Hello everyone, my name is Arvind Kumar. I work as a staff software engineer in Guaranteed Rate. I work mainly on Java and cloud technologies. My talk today is on empowering digital transformations using cloud and Java technologies. Let's start. So, this is my agenda today where we talk about synergy between cloud and Java, features, overview of both the technologies. We see what is serverless and CI/CD pipelines. We'll have a demo and we have the summary. Introduction to cloud services. So the cloud technologies, this represents a transformation approach where we manage and deliver IT services. So this is by providing the on-demand access to all the IT resources such as servers, the storage like S3 or the storage and the databases over the internet, right? So traditional approach was we earlier, right before cloud computing, the IT infrastructure, it requires a lot of upfront investment. We need to first decide how many servers we need and everything, right? And then we used to build the applications, right? So in cloud computing, we can decrease that. So we can start small and over time we can increase, right? So this is giving a big benefit to the organizations which are leveraging this flexibility and efficiency of using the cloud computing. So Java role in modern software development, we have the Java's philosophy, right? One of the main pillar is portability, where you write one Java application and you can run it anywhere where we have a JVM, right? You can run an application in Java, you can write an application in Windows, take the class file or bytecode, and you can run in any of the JVMs like in Linux or Mac OS. You can get the same output. So this portability is one of the main feature, and there are very robust frameworks for Java applications, like where we have a Spring Boot, Micronaut. Here we can simply develop scalable applications which are having high performance, right? So the TIOB index, this is the indicator where we can gauge a programming language. So Java is consistently high in this, and the Java is being the preferred choice by enterprise applications. The reasons is behind the extensive library support and the community support. So if you see the cloud and Java growth, we talked about it just now, the reasons why cloud computing are being very adaptive for the business and organizations. This has become the backbone of the digital transformation and enabling the business to scale. They can innovate more because they can optimize the cost like never before, right? So based on this, there are staggering numbers of the future prediction. Like we are reaching about 832.1 billion. The global cloud computing market is going to reach 832.1 billion, and the growth rate is around 17.5% annually, right? This reflects that how the business are relying on cloud computing for their operational and strategic needs. So here we'll talk about Java's enduring relevance. So simultaneously, Java is going to be the cornerstone of the software development ecosystem. Even though this is very old programming language, we still see that enterprise environments are being using Java because of the robust ecosystem, the platform independence philosophy, and it can be seamlessly integrated with multiple other systems. They have a lot of support for Java-based libraries. So the synergy between both Java and cloud, we'll see we have a lot of other things which just now talked about, scale and portability. So we'll see how it actually works here, right? So when we say scalability, cloud have something called as auto scaling option, where the ability to automatically scale based on demand, we can do easily in cloud, right? And similarly in Java, we have multi-threading concept, and which is very high performance, where Java can handle many users at same point of time, right? How it handles, it have something magical called garbage collection mechanism, where any Java application, if there are unused objects or unused items, it automatically deallocates the memory for other requests to happen, right? Whereas in C and C++, you need to do it manually. In Java JVM, it does automatically. So the cloud elasticity is nothing but how all the cloud providers, right, how they do auto scaling. It will be explained in few minutes. So here we take an example of an e-commerce application, how it handles huge traffic surges during holiday seasons, right? Automatically, they can increase the number of replicas they need for the application to handle the request for that increased traffic, right? So once the traffic is down, then we can automatically decrease the config parameters so that you can decrease the cost without even manual intervention. So here in this depiction, we show how auto scaling is handled we have a load balancer, we have two nodes and Route 53, and we have the load balancer which handles the traffic request. It goes to the applications. We have 3 Java instances in the right side. We'll see the features and the overview of both cloud and Java here. So we briefly talked about the philosophy, write once, run anywhere. Similarly, this kind of philosophy is going to complement when we use cloud, because we write a Java application has this write once, run anywhere philosophy is there. You can run in any of the cloud platforms, right? This increase the redundancy and cost optimization. You can deploy the same Java application in AWS and GCP together. So there is one example which we are talking here about a financial institution which uses both AWS and cloud platform for redundancy. And the core principle of Java is write once, run anywhere, right? So this is going to complement it. Here we are seeing the portability in both Java and cloud. We have one AWS cloud where we have a Java application deployed. We have Google Cloud and also the Azure. All of them are having the same Java application. Going next, we have the next feature, which is resilient. This ensures the highly availability and fault tolerance of the cloud services, right? So in cloud platforms, this is inherently built. How it built, we'll see. We'll see some examples. So Java platforms, when they combine with cloud native architecture, we can get the design features like automatic recovery from failures, handle unexpected surges in demand. It automatically increases the number of lift costs we need based on the incoming traffic, right? And cloud enabled resilience. This is using the regional failover and auto restarts and backing up the systems. Whenever there is a Java based application is deployed in AWS or Kubernetes, it can take the advantage of all these features and self-heal, right? Similarly, in Java, we have a strongest application programming language where we can do exception handling in a very great manner. And we have a lot of support for logging frameworks like Log4j. In Spring Boot also we can integrate with a lot of other tools like Kibana and Elasticsearch, where we can debug the issues. We can also use Grafana for alerting whenever we have let's say there are 500, when we are getting 500 exceptions, right? We can handle it. If there are 500 errors in a particular time frame, we can raise an alert to the servicing team, right? So those kind of things we can do here in the logging. Similarly, in AWS side, we have in cloud side, we have AWS, Azure, and Google Cloud logging. We can monitor this and combine it. It makes a very resilient application, the combination of both cloud and Java applications, right? So here we have a healthcare application which is running 24/7. So here this has been deployed in multiple geographic locations. So this is going to be a resilient application by default if you are using cloud. You don't have to do anything manually because it will take care automatically, where you can see here in the example, US East, it is being deployed to services, and in West. If there is any problem, the failure will happen without manual intervention. Similarly, we are seeing the diagram here on the exception handling, how we are going to handle the AWS Cloud Watch, and we can watch the cloud trail to see what are the exceptions happening. So we talked about this, right? This is nothing but cross-cloud deployment scenario where we can deploy the Java application in multiple clouds, right? So if you see that in real world scenario, we can adapt this multi-cloud strategy for below reasons, right? So one thing is we can avoid vendor lock. We don't have to stick for one particular vendor for a long time, right? And also this will enhance the resilience to geo redundancy. How it happens is, let's say we have an outage on one particular vendor, on one particular Google, let's say cloud platform. We don't have to stick to that so that we will be completely impacted. If we deploy the same application in cross-cloud deployment scenario, we'll have that advantage of having the redundancy for this. So we'll having a backup on other cloud platform. Our application will be available even though there is an outage on the current platform, right? And the Java's role in cross cloud, the same philosophy, Vora philosophy, makes it like very advantageous, where we have the same application being deployed in different clusters using Docker and Kubernetes. We will see that example in few minutes on how we can containerize an application and deploy it in K8. And below the steps, how we'll develop it in Spring Boot. We will deploy, we'll containerize, package this complete application using Docker, and we'll ensure it runs consistently with across the environments, and we deploy this in Kubernetes. So here we talk about this with an example. So let's say we have a big retail company which is running in North America and also in European operations, right? So here we are choosing two different platforms, AWS and Google Cloud. So by using this, we can deploy it in both different cloud platforms, which enables the cross-cloud deployment. So there is no vendor lock here. We don't need to be tied to particular vendor. Resilience and redundancy is happening here. Even though there is an outage, we don't have to worry. And cost is optimized based on whenever there is, let's say there is an offer on European side. So the customer can take that advantage. Here this depiction shows how it happens. Docker Hub, and we have two different regions with two different cloud platforms deployed on same Java application. Let's see the overview. So we have AWS, Microsoft, and GCP. Each of them are master in their own features. Most of them are common, but Google is specialized in big data, machine learning, and data analytics. Same goes with Microsoft. And Amazon has been a leading cloud provider with a lot of extensive global support and advanced features. In coming to microservice architecture, this is an architectural style where one big application can be composed to several independent tasks, right? Or which can be accessed over network. So if we do comparing to monolithic architecture and microservices, we have the following advantages, right? We have scalability, flexibility, and fault tolerance. Fault isolation, where we can take one example where, like, if one of these small activities failing in monolithic architecture, entire application is going to be down. Whereas let's say we are running a report and it is in monolithic architecture, because of that there might be a lock on the DB and it might impact the entire application. Whereas in microservice, we don't have to worry about it, right? The reporting or any wire transfer or any kind of banking activity, right? Everything can be divided into small independent service, and one service, if there is a failure, it won't impact the other services. So that's where we get this fault isolation, and we have a flexibility. Let's say there are more number of users using a particular service, we can scale up that particular service. So we achieve flexibility and scalability using that. And using Spring Boot, we can create these kind of applications very easily within no time. Yeah, we're going to talk about serverless computing. Here, serverless computing is we run the code and based on the two events without even managing or provisioning the servers. Will not have any server, but we can run the code using. So that's the reason it's called serverless computing. One good example is AWS Lambda, right? We can execute a Java code or a Python code based on the events or a HTTP request. So I can take an example here, right? So let's say if you're using AWS DynamoDB Lambda as your database server. So let's say for every new user login, you want to do some reporting stuff. You want to update something on when did this user log in or any other extra reporting kind of activities from the backend. So you can enable a database stream and we can create a Lambda. You can do the business logic there and we can store that in an RDS, right? So that's one of the example where you can use this without no need to worry about the infrastructure. We just focus on the business logic, right? And it is very cost effective because we don't need to worry about it because cloud provider is going to take care of this. CI and CD integration. So this is one of the primary thing which is happening in all the organizations where we have cloud and Java services. So This benefits faster development and quality. We'll see how it happens, right? So there are many tools like Jenkins. So let's see the definition. CI/CD stands for continuous integration and continuous deployment. So this practice enables frequent code changes and deployments for your Git repos, right? Let's go to the old example we have. Whenever there is a new change, in our traditional approach, we used to create a build and we used to manually deploy it in a server on a particular day. And let's say if you want to do it on production, let's say you have 8 nodes, you need to do everything manually, right? So after cloud computing and integrating with CI and CD, whenever the developer changes a code, an automatical build can be triggered using Jenkins, and it can be easily integrated to GitLab, which automatically builds the application and deploys it in a particular environment, let's say dev or QA, right? This will improve the faster development cycle. This automates the testing and deployment process, which will reduce the development time. And so it will be easy for the team to find early bugs before even going to prod. So there are 2 real world scenarios here. Both are different examples where financial institution is using a cloud and e-commerce application is using microservice architecture, right? The outcomes are simple, right? We saw the examples before. We have an improved scalability and performance using cloud technologies and faster development and reduction in the operation cost when we use the cloud services. Similarly, in microservices, there is a system readability and reduce the time to the market using the new features. Because if you like integrate microservices with CI and CD, so the deployment life cycle will be decreased. So these are the key takeaways for the key concepts and takeaways in the entire talk. So this is virtualization, containerization, and serverless computing, right? So virtualization abstracts the physical hardware and creates virtual machines, optimize the resource usage. This is happening using virtualization. And containerization, Dockers will have the applications for consistent developments, and K8 will have the container and deployment and management here using K8. So the serverless computing, we focus main on the business logic without even worrying about how to manage the server. And so this is leveraging the cloud platform infrastructures. So we'll see a demo on how we are going to achieve this in a simple demo, right? So here we are seeing a Spring Boot application where we have a REST controller. So this is nothing but a Spring Boot app. We have a get mapping, which is /hello. So whenever a HTTP request is coming, so this will be called and the request is being processed. We see a Docker file here. So this Docker file is nothing but the containerization. Docker file. This is used to containerize the Spring Boot app. It's used to package the entire application and its dependency into a container. The first line says from OpenJDK. This line specifies the base image of the container, and it's making sure that it is available to run the application, right? And we are setting the working directory to /app and copying the jar file which is created on the Spring Boot jar, and we expose 808.8080. This is the port number where we are running it, and the enter point specifies the command to run the container. Going next, the Kubernetes deployment YAML. This deployment YAML file here we are talking about, we are just defining the type of deployment, if you see. And we have the most important configuration is in the specification we have replicas, right? So this replicas will tell the Kubernetes application how many instances of the Java application is going to be deployed, right? So in this example we set 2, where there are two. This signifies that there are 2 replicas of the same Java application which is running, and this ensures the highly availability of the application, right? And also if you see the spec and container, so here we are telling what is the application name and the image. So here when we talked about cross-platform deployment, cross-cloud deployments, so we talked about we can deploy multiple application in multiple. So here in the image, we mentioned the Docker image used for this container. This is now pulled from AWS, but we can change it to Google Cloud or whatever we need, right? So this signifies which particular we need to use. So this relevance of this Kubernetes deployment, or like this automates the management of containerized application. So here we will tell where to be deployed and how many replica or should be installed. And this can be automatically automatical scaling is being added here. So this can be used for that. And this YAML file here, this Kubernetes service YAML file, here we define the application API version, the name of the application, and the load balancer. Here, the Kubernetes service file takes the responsibility of exposing our service to the public, right? Where whenever a HTTP request comes, Kubernetes load balancer will take that and it will decide which replica to be called, right? If there is any issue with one of the application, it automatically goes to the second one. Load balancer will take care of that. And the target port number, we define it here. And the Terraform script here, this is making that complete infrastructure as code. We define, instead of doing the configuration every time, DevOps engineers use this and the developers write Terraform scripts using Terraform command init, and once everything is verified, they'll do apply. Here we are defining the source AWS module. We have the cluster name, the cluster version, and we define the node groups here, right? So what is the desired capacity, max capacity, and min capacity? At least one node, maximum 3 nodes, and the desired capacity is 2. So this here we are defining whatever we wrote there. We can have the infrastructure as code. Whenever is needed, we can run the script and it will create all the infra. This is nothing but infra as code. The final output of this demo is we are running a K8 cluster with a load balancer, and the final output will have a response from the Spring Boot microservice. Yeah. So a simple Spring Boot microservice using Docker, we containerize that and it is deployed in a EKS Kubernetes cluster. And we are exposing using the load balancer. The final output is a very highly scalable and very available and scalable application, which is accessed via public URL, right? So here this architecture, if you see the Spring Boot microservice along with the Docker, K8 and cloud service, this makes this architecture ensure that application is resilient, scalable, and portable across around all the cloud platforms. So the conclusion is Java represents a powerful synergy, right? The application is made, the microservice is developed using Java, which is a powerful programming language which we discussed, and this drives the digital transformation across multiple industries, right? You take Netflix, e-commerce applications like Amazon, eBay, and many financial banking organizations use this combination. So this cloud computing offers significant advantages, including the scalability, cost efficiency, and operation agility. This will enable most of the applications, most of the organizations, right? By leveraging AWS, Microsoft, and Google Cloud, right? So that's all I have. Thank you guys. All the best. Bye bye.